29? What? 29 out of what?
Okay, so here we go. Chapter 8. On a stretch run here. But yes, we got a ways to go. We're still going. Okay. Chapter 8 is on rational functions. This is, I believe, as I sort of glanced through the book and looked at what is left for us to work on, this is the last, like, traditionally algebraic chapter with functions and factoring and things like that in there. And then the rest of the stuff that we're going to do for the rest of the year is, I mean, obviously it's still math. No, it's not easy. But it's going to be sort of a little bit different than the types of things we've been working on before. Okay? I would be, hold your questions please. I would be so excited if there were 5 people in this class who could tell me off the top of their head the definition of a rational number. Without looking in your book. Does anyone know what the definition of a rational number is?
It's rational. Can't lie about. It's not.
A rational number.
It's more than one. Yeah, that's the only part now. It's more than one. Not a fraction.
Is any number that can be written as a fraction. Okay? A rational number is any number that can be written as a fraction. Now, when I taught you about rational numbers in algebra, we talked about it in terms of decimals that stop, okay? Or decimals that repeat themselves. Okay? Right, so 0.333 is repeating is a rational number because you can write it as 1/3. Okay? Pi is not a rational number because that fraction goes on forever, or that decimal, I mean, goes on forever without any pattern, and so you can't write it as a fraction. They tried. The close approximation is 22/7, and that does pretty good, but it's not exact. Okay? My point is, Chapter 8 is on rational functions, and so what we're going to look at is functions that are written as fractions. Right? So instead of just things like f of x equals x squared plus 3x plus 4, we're going to say f of x equals x squared plus 3x plus 4 over x minus 2. And we're going to mess around with that. Okay? So that's sort of the tone of this chapter, is taking the functions that we've looked at before in the other chapters and looking at them as fractions. Okay? Make sense? Yeah, yo. So, very first one is the easiest types of all. Of course, this chapters always start out easy.
Obviously.
And that is when you have functions that are called inverse variation. Okay? We've talked about before direct variation. Direct variation is when one thing goes up, the other thing goes up also, or when one thing goes down, the other thing goes down also. Like for me, example, when your height increases, your good looks increase as well. Okay? Right, Lane? Right? Okay? And when you get shorter, or shorter the people are, for example, the less money they make. Those are direct variations as well, right, Courtney? Okay. Inverse variation is when one thing goes up, the other one goes down. And so, for example, if the amount of time you spend exercising goes up, your weight goes down. So time exercising and weight would be inverse variation. Another one is when your income goes up, the number of children you have tends to go down. people who have more money tend to have fewer children than people who have less money.
Is that real?
Why is that? Yeah, that's real. That's a real thing. Why does that make no sense? Why do you think they have all the money? They don't have any kids. You kids cost millions of dollars. Yeah, no, I'm being facetious there. Yes, but you would, Austin, you would think that would be true. You go, okay, we don't have a lot of money, we shouldn't have a lot of kids. But people who don't have a lot of money, generally speaking, there's a general trend. This doesn't hold true, with all individual cases, but generally speaking, people with less money have less education, and they don't think through things like that. They end up making accidents happen. They make bad choices, which is why they don't have a lot of money to start with, because maybe they dropped out of school.
And then the state takes it.
And then the state takes all the money. Right. Okay, anyway, so direct variation.
I'm probably kidding.
Okay, so direct variation, those functions always look like y equals some number times x, and we've worked with those before. Those aren't going to be the ones that we're going to do, but I just wanted to put that up there so maybe you would remember those from your past. Inverse variation is y equals a number divided by x. So k is the constant of variation. And that is a number that you need to find. Another way that you can look at this is if you said, hey, I don't like fractions very much, you could multiply both sides by x, and then you would end up with x times y equals k. So you have an example of inverse variation if when you multiply the x's and the y's together, you always get the same answer. Almost worth saying again and writing down. You have an example of inverse variation when you multiply the x and y together and always get the same answer. Okay? I'll do an example in just a second and you'll go, oh, okay, I get it. I see what you're doing. I'm going to give you a table of values in a second of x's and y's, and I'm going to say, is this inverse variation or not? And you're going to figure it out using that little fun trick. Do you understand? Okay, so let's do some examples. So you tell me inverse variation or not. 2, 4, 10, 15, 15, 7.5, 3, and 2.
Yeah.
Yeah, right.
30.
30, because 2 times 15 is 30. 4 times 7.5 is 30. 10 times 3 is 30. And 15 times 2 is also 30. So this is inverse variation. And my equation would be y equals
30 over x.
30 over x. Yes, we've messed around with this a little bit before. We did this with the 7th grader?
Yeah.
So we're doing 7th grade math here.
Yeah. Oh, the guy tutored her.
No wonder Forrest got it right.
So these side
All right, let's play again.
2, 4, 7.
No. 0.2, 0.5, 1.0, 1.5, 8, 20, 40, 60.
We're not gonna.
No, because they're both increasing.
With these, are we?
What's that?
They can't be inverse because they're both increasing.
Nice. Okay, so Forrest gives you a little secret there to save you the trouble of doing any math at all. as we talked about at the beginning, inverse variation means when one thing goes up, the other thing goes down. So this one here, you can see the x's were increasing, and then these were decreasing, so that gives you at least a chance of it being inverse variation. Since in this case the x's are going up and the y's are going up, you know it is not inverse variation. Is it direct variation? 0.2 times what is 8?
4.
That would be 0.8.
Wait.
0.2 times what equals 8?
I thought it was 0.2, 40.
40, okay? So 0.2 times 40 equals 8. 0.5 times what equals 20? 40.
Okay, so
1 times 40 is obviously 40, and 1.5 times 40 is 60. So this is an example of direct variation, and the equation for that would be y equals, but what is k?
K is
40
40,
x.
Wait,
Okay?
why are you doing it like that?
That's
How would you like me to do it?
Why are you doing like, oh.
Why did you choose?
Because it's not inverse. Why did I choose 40? Because I solved this first one in my head, and then I needed to check and see if they all worked by 40, and since they do, then that means it's direct. Okay? Since 8 divided by 0.2 is 40, and since 20 divided by 0.5 is 40, and 4 divided by 1, da 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 da, then that means it's going to work out. Okay? All right, let's keep playing. It's so much fun.
I'm gonna leave it. Point 2.
0.2.
What's bad? 1, 2, 3, 4.
Okay? What do we got going on here? Nothing. Big fat nothing. It's yes. Yes, this is an inverse relationship.
Increasing and that one then?
Okay? One of them's going up, the other one's going down. So that's the first part that we need. And then when you multiply them together, what do you always get? 8. 0.2 times 40 is 8. 0.5 times 6. What? So y equals 8 over x. All right? All right, let's do one more.
So when we do it like this, like if there's ever a 1, it's always going to be,
The 1 is the easy one to look at, huh?
yeah.
Always looking for the easy way out, Lane. All right.
This one's yes and no.
Okay, this one, the x's are going up and the y's are going down, so it's a candidate for inverse. Why is this a no? 0.5 times 40 is 20. 1.2 times 12 is 14.4. Okay, so
No,
neither.
it's already wrong.
And that one's and so
Yeah, and we know that it can't be direct because for it to be direct, when these are going up, then these would also have to be going up. So it's no solo, neither direct nor inverse variation. Okay, waiting.
But one was going up and the other
Was going down, so it was a candidate for inverse relation. But then we have to check and make sure by multiplying these together to see if we get the same answer every time.
So really, you gotta do one.
You do have to, yeah. True. All right, so let's kind of go the other way a little bit.
No, it's only one certain one. It's like the first one.
Maybe both.
But it can't be close. It's going to be one or the other.
technically yes, there's power symbol in that.
Okay, so then they might also just tell you straight up, voice. They might also just tell you straight up at the beginning that they do, let's just assume that they do vary inversely. So if x equals 4 when y equals 12, what is my equation going to be?
Y over X.
Y equals what?
It's gonna be 3.
No, it's 4 times 12, guys.
48 over x.
Yeah, I knew how to do it.
Okay? Because when they're inversely, then you multiply them together. What some of you were doing was, if it said instead of inversely, if it said directly, then you would say, yeah, y equals 3 times x. Okay? 3 times 4 is 12. But it didn't. It said that they vary inversely, so that means you have to multiply them together. Okay? All right, quick look at what the graphs look like. So let's graph that last one, 48 over x. And this is the general shape of inverse variation. You can see, hopefully what's happening here relates to what we were talking about before. Please zoom out just a little bit so you can see a little bit better. Okay, there we go. As the x gets bigger this way, what happens to the y?
It's smaller.
It gets smaller, so that means it gets closer and closer to the x-axis. If I went backwards for some reason, as the x gets smaller, the y gets bigger. And then the same thing is true on the negative side. So these are called branches. You have one branch of the function right here and one branch of the function right there. We don't need to spend too much time on those just yet. We will do that more in the future. Okay? Sound good? Assignment. So good to be back.
Wasn't I stupid? Okay, you just make it I watched you. I was writing on it. I see, yes, that's so many problems.